Hey there, my name is Jabin Shah, and this is the video for Milestone 2, that is test and analysis for iTrust and checkbox for the CSC519 DevOps project. Now I'll directly just talk about the milestone. In this milestone, we have extended our work in milestone 1 and demonstrated techniques related to fuzzing, test case priorization, static analysis to improve the quality of checkbox.io and iTrust. Like the last milestone, we do have a couple of prerequisites like VirtualBox and Baker, and if you click on these two links, you will be taken to them, and there are instructions for you to install them. The next thing that you'll need to do is to clone this repository. So you can copy this command and run it on your terminal, and it'll download the repository for you. If you haven't really looked at the video from Milestone 1, I would recommend that you do that first. I'll be linking that video in the video description below. In that video, we describe more in detail about the build and deployment process and what we are doing with the roles and Ansible. In this video, I will be just focusing on the new additions from this particular milestone. So let's go ahead and do that. So the old roles from the milestone 1 are listed here, and there are a couple of new roles, fuzzer, checkbox analysis, and iTrust analysis, which will help us with completing the goals for this particular milestone. Now we can use this command to start with the play. Now I'll just skip to the end and I'll see you on the other side. Now since the running of the play has just completed, we can go back to the repository, and once complete, the Jenkins server will be available at this address, and 4 new jobs are now configured on Jenkins, 2 for checkbox and 2 for iTrust. Let's now see what each of the jobs do. In this milestone, we have completed the following task. We installed a Jacoco plugin in Jenkins for Java code coverage for the iTrust application. It will essentially create a summary report for the instructions, the branch, complexity, the lines, methods, and classes, and the coverage of those things for each of the classes in the iTrust application. I'll just go to the iTrust 2 and then build it. I'll cut to the point when the build has completed its execution, and I'll see you on the other side. Now the build is edging towards its completion, and as you can see, the build has been successful and a Jacoco plugin has executed, and we can go ahead and have a look at the file. You can see the build is successful and a coverage report summary has been created. So code coverage essentially is a measurement of how many lines or blocks of code are executed while automated tests are running. And you might want to use it as an exit criteria for each of the milestones. That might be a good thing to do. Also, while code coverage is a good metric of how much testing you're doing, it is not necessarily a good metric of how well you are testing the product that is under consideration. There are other metrics other than code coverage to ensure that quality. So now let's go back to the repository and have a look at the next task. So we have also developed a tool that automatically commits new random changes to source code, and it will trigger a build for the run of the test suite. And we simply use a pseudo-random number generator that has a seed value ranging from 1 to 100, and the code for the same can be found at these links. And we have made the following changes, and we have essentially swapped certain operations with each other, swap certain characters, and in some cases just replace strings with other strings. Over here, you can have a look at the 100 builds that we ran on March 9th, and each of these builds would give us a report like this where it would include the test failures and the errors generated by each of the builds and the reason behind them. We also wrote an analysis script that would analyze the results of the 100 build jobs and create a report. And you can have a look at the saved report here. So in this one, this is the entire report for the 100 build jobs where we passed a total of 5,000 cases.
failed a total of 420 cases, and there were errors of about 1400 cases, and the total time has been mentioned. Also, we have a file that stores the changes that were made in each of the build, and you can have a look over here that with the seed value of 1 for build 1, this was the old line. This is the new line that has been changed. You can see that the number 1 has been replaced with 0, and the path where this change took place was in failure handler.java. Like that, we have a total of 100 cases, and in each of them, we report the number of changes that was made in that particular build. And then once the build has been triggered, we revert back to the original code before fuzzing it again and pushing the code to the Jenkins for the next build. Now I will simulate the fuzzing and analysis job for about 3 builds, and let's go ahead and do that. You can see that these were the following changes that were made. It is similar from the file that was shown earlier, and it is ready for the next build, and it will trigger the build in about 10 seconds. And since in the last milestone we configured the build to be triggered when a push is generated, this would in fact execute a build for iTrust on Jenkins. And if we just have a look right now on the Jenkins server, we can see that a build has indeed been started. And if we have a look over here, it would continue the build process, and then it will check whether or not tests are passing or failing. And now I will cut to the time when all the 3 builds have completed their execution. I'll see you on the other side. The third build just timed out. And you get an idea from this that if it runs for 3 builds, it can run for 100 builds. Now let's go back to the Jenkins server and have a look at the build results that were stored from these 3 builds and perform an analysis on them. Now the build results are stored in the home directory at build results. You can see that there are currently 3 folders, and each of these folders have the surefire reports with all the tests. Now, if we run python analysis.py, it gives us the number of tests that were passed, the total number of tests that were failed, and the errors that were encountered, and the total time it took. So that was it for the fuzzing and the analysis operation for iTrust. Now let's go back to our repository and let's execute the next task. So for the next task, we have modified the pom.xml file with support for FindBugs. And for a new job, that is iTrust 2 test static, to be started on Jenkins. Also, we installed the FindBugs plugin to support the same. We tried to use the warning next generation plugin, but Jenkins job builder does not have support for this plugin. But on manual running, it works. So when the JJB starts the support, a simple publisher code should help with the same. So if we go to the Jenkins dashboard and have a look at iTrust 2 and start a build job for it right now, and I'll let it run and I'll see you at the end of it. Now the FindBugs report is being generated, and all the dependencies that are related to FindBugs are being downloaded. And once complete, a report would be created and the build would be failed because of the threshold values that we've set. Now the build job has completed and the FindBugs plugin has just completed its execution, and a report would be created. As you can see, the build has been failed because the number of warnings that were created under the normal priority section was greater than the threshold that was set by us. Now let's just have a look at the report. In this build, the total number of warnings that were of normal priority was 14, but since we had set a threshold value of 10, it failed the build. Now we can go back to our repository and move on to the next task. So finally, we extended the checkbox.io to analyze and create custom scripts for the same. And then we used a test script to fail the build when it was necessary. The custom metrics that we created are the long method, which fails the build if a method is longer than 100 lines. Cyclomatic complexity, if the number of conditional or looping statements is greater than 15 in a function. Then max if conditions. So if the number of conditions in the if statement are greater than 15, and maximum parameter count. It fails the build when the number of parameters passed within a function is greater than 10. And finally, max nesting depth. It will fail the build if the depth of if-else conditions statements is greater than 15. And let's go ahead and do that now. So if we go to the Jenkins dashboard, we have a build job ready for execution. And if we build it now, it would run the analysis job on the checkbox.io service. And then once the analysis script is completed its execution, it will run the test script and it will check whether the conditions have passed or not. You can see that it passes 2 tests and it fails 3. It also gives a list of methods in which the test criteria are failed. So for example, in long method checking, if the lines are less than 100, it shows that 2 functions, hash HTML blocks and convert tree to HTML, are greater than 100 lines of code. However, if we go to analysis.js and we modify the code so that it passes the tests, so if we increase the value of nesting depth by 1500, lines of code by 10,000, max if conditions as 1500, simple cyclomatic complexity as 1500, and parameter count as 1000, it should hopefully pass the build. Now if we go ahead and run the build job again, we can hopefully see that the build has successfully passed. As it can be seen, the test cases are now passing and there are no methods that are failing any tests. So that's about it for this particular milestone. We'll see you in the next one.